All right, so into this lesson, we're also doing general method, but we want to look at more complex functions using general method to actually solve. Let's say we have y equals 2 into x 2 over x squared, then plus 1 over x, then plus 3. How do you define the derivative of this? So dy dx becomes can write this as 2 into 1 over x squared, because this would multiply and you have 2 over x squared, then 1 over x, then plus 3. Okay, wait, I've not differentiated at all, so then let me use this sign here. So let me just say y. I'm just simplifying so that I can differentiate, and y now becomes 2 into, since you are familiar with indices, that should give us x to the power of minus 2. Then this should be x to the power of minus 1, then plus 3. And I think now I can now take my derivative, and that becomes dy dx becomes 2. Then I bring down this minus 2 down. That's the first step. Minus 2, then x, then minus 2, then take away minus 1 from minus 2, minus 1. Then plus, bring down this minus 1. I have minus 1, x into minus 1, then minus 1. Then plus 0, because 3 is automatically 0. And so I have dy dx is equal to 2 minus 2. You have minus 4 x into minus 3 raised to the power of minus 3. This, then plus times minus. What do you get? You get minus 1. I don't need now 1. X, then x minus 1 minus 1, you have minus 2 plus 0. And so basically I can rewrite this by saying minus 4 over x 3 raised to the power 3, then minus 1 over x squared, because we are going to have that, and that's the y dx. So this is how to solve questions that involve raised to the power of minus number, or 6 over the variable. All right. So let's take this another example. Y equals 6 over x to the power 3 minus 2 over x. So how to differentiate this? First, I have to write this in a very simplified way so that I can differentiate. And I'm going to have 6 into 1 over x cubed, then close up the bracket, then minus 2 into 1 over x. Okay, so I can write this as y equals 6x raised to the power minus 3 minus 2x raised to the power minus 1. Then I can now differentiate. So dy dx now becomes, multiply this by this, so I have 6 into minus 3, then x, then subtract minus 1 from this, I have minus 3 minus 1, then minus 2, then bring down this guy here, now you have minus 1, then x minus 1, then subtract minus 1 from this, minus 1. And so what do I have? I have dy dx equals 6 times 3 is minus 18. That's minus 18x raised to the power of minus 4. Then minus 2. Minus 2 times minus 1. Minus times minus is plus. 2 times 1 is 2. And then minus 1, you have x to the power of minus 2. Alright, so this is our answer. So we can decide to write that as minus 18 over x to the power of 4 plus 2 over x raised to the power of 2. So either you leave your answer like this or you leave your answer like this, depending on how the questions come. Okay, then let's see another example. Let's say y equals 3x squared minus 2 over x to the power of 3 plus 4. How do I differentiate this? So the first thing, I have to simplify this by saying 3x squared minus 2 into 1 over x cubed plus 4. And so I have this as 3x squared minus 2x to the power of minus 3 then plus 4. So my dy dx becomes 3 into, I'll bring down this 2. So that's 2x, then 2. Subtract 1 from this, I have 2 minus 1. Then minus 2. Then I bring down this minus 3. So it becomes minus 3. Then x, subtract 1 from minus 3. I have minus 3 minus 1. Minus 1. Remember that anytime you differentiate a constant, you have 0. So I don't need to write that. So then dy dx becomes 3 times 2. You have 6x to the power of 1. 2 times 2 minus 1 is 1. Then minus 2. Oops, sorry. Minus 2 times minus 3. Minus times minus is plus. 2 times 3 is 6. X. Then minus 3 minus 3. Minus 3 minus 1 is minus 4. So I could actually write my answer as 6x plus 6 over x to the power of 4. Whichever way I want to leave my answer is permitted. Alright, depending if you're doing an objective question, depending on which options are there. Alright, good. So this is how to use the general method to actually differentiate any function that you have.